So why do we want to focus on real-time data? Well, because concurrency is hard. And why is it hard? Because when we start learning programming, we start like with very basic exercises of, like things run one at a time and one after the other. Like you have like lines of code and you have one line running after the other. And this is like extremely simple. But when you add concurrency, things go a bit more crazy, right? And this second line that says like combining synchronous code with asynchronous code is harder. What I mean with that is that if you think like, oh, I'm going to be an expert on asynchronous code, right? There are some things that when you work in asynchronous code, having some synchronous functions inside there can break some assumptions that you might have. And we will see some examples of that later, okay? So when you work with concurrency, you have like some stuff to look for, like race conditions. This is when, depending on how long some task takes other than the other, you have like different outcomes based on that. And data overrides. This, what I mean by that is when, when you have something that's like changing, if you're not careful, you might miss some of those updates, right? So you might be subscribed to something, and depending on how you handle that data, you might essentially like forgot about some of those updates. And then back pressure is another thing that we will see a bit more later. But back pressure essentially is when you have like something that creates tasks in some way that you have to wait. You can get like a memory overflow because you cannot keep up with them. Then, if we look at the numbers, like there's a study that I found in one article. In the notes of these slides, you can see the source. It's just like one study of difference, but that study said that 9% of bugs in software development are due to concurrency. And even though it doesn't look that much, these are the hardest bugs, right? Because they are extremely hard to reproduce because, again, like a race condition, it might happen, it might not happen. So maybe you have a bug in your system and it just happens once every year, right? And if you're not, like, how do you debug something that happens once in a year? It's extremely hard. Like you have to analyze your code and understand what could be happening, right? Now, if we look at the real-time data, which is what we're talking about, then it's even harder, right? Because real-time data, first of all, works with concurrency. Like you have like a lot of data coming through, and you have to juggle with all of that. But then also the things come like extremely quickly, right? You have like every second, every millisecond, like depending on the platform you're working on, every single time you're like receiving so many information, and you need to be able to understand how to process it and so on. So there are more things to look for, like missed updates. Also, like multiple sources of truth. That's another problem on real-time data, is that sometimes sometimes what you have is just like one single stream of data, but the way that you structure this data, you might have some pieces of state that they are closely related to each other, and then they suddenly fall out of some synchronicity, and then how you compare those, it's like extremely hard. So it becomes challenging essentially. So this is just like a small exercise just on about concurrency. Imagine that we have like this component in React, right? It's just a component that shows the balance of an address, and then so we need to load the balance of this address, yeah? So we create a state, we have it here, then we will render the balance when it's there, and if it's null, which is like, well, it's loading, then we show it's loading. So in React, how do we load for stuff? We do a use effect, right? The use effect is what let us like create side effects and so on. So the idea here is that whenever the address changes, what we're gonna do is first put the set balance to null to make sure that it becomes loading. And then we will load the balance of this address, and when we have the result, we just store it. Yeah, seems simple enough, and it should work, right? Like every time that I change the address, React will see that the address has changed, so it will run the effect again. It will put the status back to loading, and then we load the balance, and we'll set the balance. But as the title said, this has a bug. Right? Can you see it? Mike?
I think instead of set the balance null, we need to make a loading state and set the loading. No?
No, like this is working fine, right? Like imagine, right? Like we have initially like the state is null, so we show loading. Then the first time the balance is loaded and we show the balance. But now the user changes to a different account, right? And when it changes to a different account, the first thing we do is set the balance to null so that the component shows loading while it's still loading. So this is fine. Well, there's that one.
I think because we don't get the balance from what I mean is after we get the balance once, it shows the balance when we first time fetch the balance, but when the balance update, we don't get the balance, the updated balance. I think something like that.
I'm not sure I'm understanding, but like when you load the balance of a new address, it will give you the new balance. Like imagine that load balance works perfectly, and that's like this function is working fine. Like the problem is in this component itself. There.
Yeah, this may be an edge case, but let's say load balance function is updating, fetching the balance and updating it, and the use effect reruns on change of address. So if while load balance is fetching the balance, address changes. So that may be inconsistency in data.
Come again. I think that you might be in the right track. Yeah. Like, can you explain it again?
Yeah. So let's say load balance is getting the balance, and let's say it takes 2 seconds.
Yes.
In between that 2 seconds, let's say the address changes. So that the value that it gets, it's of an older address, and the function now has to rerun.
Yes. Yes. You nailed it. So, and there's a bit more than that, but that's exactly what it is. So what he explained is that imagine that load balance takes some time because it's it's fetching, right? So it might happen like let's put like a worst case scenario. Load balance takes 10 seconds to load the balance. Yeah. So you put like initially like it gets in loading, and then the balance starts calculating, and after 5 seconds the user like is tired of waiting and selects a different address. Yeah. When it selects a different address, like the previous load balance is still running in the background, right? After 5 seconds it will receive the data, but it's not yet there. But React will come here and it will say like, well, I'm setting the balance to null, and now I'm loading the balance of a new address. So now you have like 2 load balances running, one of the previous address and one of the new address. Yeah. And then what happens after 5 seconds is that the first load balance will resolve, and now it will call set balance of the previous address, right? So now you will see that the user will see the balance of the old account for a moment, right? And then after 5 seconds, the second load balance will resolve, and then the balance will update to the new one. The only thing is that it could even be worse, right? Because here we said, like, imagine that load balance takes 10 seconds to load, but now imagine that load balance like sometimes takes 10 seconds, sometimes takes 1 second, right? And imagine that the first time that you load balance of an address, it takes 10 seconds. And we have this case again of like the user at second 5, like it's tired and changes to a different address. But now the second time the load balance of the new address is getting called resolves almost immediately. What will happen in this case? Well, what will happen is that the user will see the balance of the new account, looks great. But then after a while, the first load balance will solve, and it will replace that balance with the account of the previous one, and it will stay like that forever, right? And that's extremely bad, because now you're showing like the wrong balance, yeah? So this is the thing, right? Like we have something that is like, oh, this is like inoffensive. Like you write this thing and you think to yourself like, oh, this makes all of the sense in the world, and this thing is bug-free. But turns out it's not. And probably you try it, and you will see the correct result. And you think like, oh, I'm a genius. I built my balance component, and But then you go to production, and sometimes you have a bug report of someone saying like, hey, my balance is not correct. And then you look at your code and it's like, what the hell is going on here? And you try to reproduce it, and you cannot, right? And this is the kind of thing that makes it extremely frustrating, right? Like you have a bug and you cannot reproduce it because, well, it just depends on the timing of things, yeah? Now, I don't have like a slide on like how to fix it, but do you know how we would fix this? Like, how many of you are familiar with React? Okay, a few people. That's good. Well,
Yeah, I'm not 100% sure, but I'm thinking in the lines of writing a cleanup component, cleanup function for that use effect.
yeah, right. So use effect in React, you can return a cleanup function that is like, okay, when this effect runs again, it will call your cleanup function. So in here, like you would have to add a way of like canceling this load balance, or imagine that this load balance cannot be canceled for some reason. Then what you can do is like put here a variable of like let is canceled is equal to false. And then inside the cleanup function, you would say is canceled is equal to true. And then in here, before setting the balance of the new result, then you check for that flag, right? If it has been set to cancel, then you then set the balance of the old account, essentially.
I mean, ideally, try to work with primitives that natively handle cancellation, like effects, observables, even abortable promises, right? Like if you look at Papi, you'll see that even the promises that when Papi returns a promise, it's an abortable promise that can be canceled with a signal. We're not huge fans of promises, but because promises are not really cancelable, they can only be canceled at a distance with like this kind of hacky way. But whenever possible, try to work with primitives that allow for cancellation when working with asynchronous data, right? Otherwise, you have to make kind of like the hack that Victor described, which is like you didn't really cancel the load balance because if it's not canceled, you cannot, and then you need to afterwards when it resolves constantly be checking like, oh, like is it still running? Like did the user cancel it, right? But if you can imagine a situation where like load balance returns like a function for unsubscribing when you are done listening, you will accomplish two things. Well, first, you just return that function to React, or it's easier to compose basically, and also you will most likely stop wasting resources because many times asynchronous functions take resources, and when you cancel them, you release those resources, right? So anyways, sorry.
So the pattern that you are just describing is like how we use abort controller.
Right. So well, probably Victor will get to that later, so I don't want to spoil it. But like one way, there are many different each asynchronous primitive has its own mechanism for cancellation. Sadly, when promises were designed for JavaScript, they thought that cancellation was not so important because things could be canceled at a distance in different manners. Like basically you could provoke, but anyways, like I don't want to get ahead of myself, but there was another proposal when promises were trying to put into the spec that are features that are basically like promises, but are lazy and also allow for cancellation. But anyways, like there are different primitives that can be used for cancellation. I'm sure we'll get to that later, and otherwise I can chime in and I can show some examples. But what I'm trying to say is like whenever you work with asynchronous data and you want to avoid race conditions, a great way of avoiding race conditions is to use primitives that in one way or another, allow you to kind of cancel the synchronous task that it's running. Yeah, sorry.
Any other question on that? Okay, so let's introduce like first a few concepts, which just to set everyone in the same position, right? So, well, synchronous code. We know what synchronous code is. It's like just a function that runs one thing after the other. So here we have like calculate average, which well, this should be a number array. Sorry about that. But you have like like some amount of winnings, and you want to know the average of that. So you can calculate the sum, the winnings that reduce, and this function that you pass here is also run synchronously, right? So reduce is a function in JavaScript that adds like calls each one of the values one by one, and then lets you accumulate the values and so on. And this happens synchronously. So you have a function calling another function synchronously, and you get the result and so on. And then we have asynchronous code, right? Which is like things that might happen sometime or later, right? So here we have, well, we're using promises, and we have like these two versions, but these two are also asynchronous, right? So we have fetch winnings, and once those winnings are fetched, then we do something, right? Here, something asynchronous has happened, yes? And now this, when we have like these winnings, like this calculated average is like calling this function, which is synchronous. So like this part over here is synchronous, but this step from here to here was asynchronous. So the whole code is asynchronous. And you could say the same thing for sync await, right? They are equivalent, right? So I think this makes more sense. Now, there are also like two different concepts that also get mixed up. So let's clear them out. There's concurrency and there's parallelism, right? So what is the difference between them? So concurrency is when you have like multiple tasks that you have to run them like simultaneously, but you run one at a time, okay? And then each one of these tasks, you can treat them sort of like synchronous. Like it runs them each task like one by one, and once that task is done, then it moves to the next one, right? Now, at some point, like on one specific task, you may pause that task, and it will start running a different task. But like it's very like I don't know. So essentially, like take in JavaScript, right? Like you can have a function that's asynchronous, and you have like a bunch of awaits. So you can think of that like, okay, this is one task, but then I run the code, and I'm guaranteed that as I'm running the code, nothing else can get in the way. But then when I receive an await, then I'm passing this task, and JavaScript will start working on a different task. But everything happens like one after the other, right? We only have one thread, and that thread is executing just one instruction at a time. You can think of it, okay? So the good thing about this is that there's no shared memory access, right? You don't have like two instructions that are running at the same time that are accessing the same pointer, which is like quite hard to deal with. And this is what parallelism does. So in parallelism is when you have like multiple threads or like multiple processes and so on. So it means that you can have like different instructions running at the same time. So this is why they are called in parallel. Yes. So the problem it has is that you have like shared memory access. So the way that you can deal with it is in some languages you use logs and mutex, which is like, okay, this process is accessing this part of the memory, so I'm going to essentially lock this part of memory so that I can only access it and I don't have like problems. And the other one is message passing, which is like, okay, let's not share memory, because like we won't go too much into detail on why sharing memory is like problematic because we don't touch parallelism here. But the idea is that, okay, we don't want to share memory, so the way that we have of communicating with each other is through passing messages. It's like sending messages from one to the other. So in JavaScript, the concurrency model is essentially single-threaded. So we don't have parallelism. This is a bit with an asterisk, though. Yeah. So JavaScript uses what is called an event loop, And the event loop is just a place where all of the tasks are getting pushed into some sort of like queue, and then they run one after the other. But there's no multi-threading. Okay, the only thing that you can do multi-threading is with web workers, but we don't you usually don't need web workers for web stuff. Like the main problem is that web workers cannot access anything on the DOM, like the object model, and then it also works with message passing, so it's a bit hard to use. It's not that great. Usually, like it's way better just to think synchronously, just like with the main thread, and that's all. Now, inside the event loop, we have two types of tasks that we need to talk about. So we have what's called macro task, and we have what's called micro task. Yes, and this has sort of like you can think of like the event loop is like the thing that allows concurrency in JavaScript. Yeah, so it has like all of these tasks that are coming through, and when one task gets paused or finished or whatever, then it needs to get another task to work on. And this macro and micro task essentially, like you can think of a way of like prioritization, right? What the event loop does is like first it will run the micro task before it runs any macro task. So how do you trigger each one of those? Is like, well, with macro task is when you do I/O. So when you fetch something, that's a macro task, or like access something on the disk, that's a macro task, or you do set timeout or set interval and so on. All of those are queued as macro tasks. And then on micro task, what you have is promise, then, or await. It's the same as a macro task. And well, there's an API specific to queue a micro task, which is like as if you did a set timeout, basically. What's important to notice is that, here I'm saying promise then. So you can think like, and what about fetch? Right? Like fetch is giving me a promise. So is that a macro task or a micro task? Anyone can guess? I love how it's like micro task, macro task, micro task, micro task. Okay, so it's a macro task, right? Like what we're doing is I/O, yeah? So, okay, like the promise itself is a micro task, right? But this promise is waiting for a macro task to finish, which is I/O. So you can think of it as a macro task instead, okay? Yeah, this is just to clear up because, yeah, like promises work with micro tasks, but they only do if they are actually resolved, right? Imagine that you have fetched something, and then, this, after a while, like this promise already has a value. Then when you want to get the value of that promise, that gets queued up as a micro task. So let's see some examples of like what happens with the event loop in JavaScript. Right here we have some asynchronous code that first console log start, then sets a timeout to console log timeout, and then does this like promise resolve, then promise then, and then end. What's the result of this going to be?
Don't run it in your computers. No one touches it.
Exactly. Using Java, yeah.
So first will be start,
Mhm.
then will be end,
Yes.
then will be promise, then will be timeout.
Yeah, exactly. Right, because remember, like in here we have set timeout 0, which means like run this thing like almost immediately, right? As soon as you can. But this is queued up as a macro task. Yes. And now we have this promise resolve, and this queues up like as a micro task, and then we have end. So what's happening here is that, okay, on the first task, which is like all of this code, it will console log start, then we'll set this task like in the queue for later, and then we console log end. So we have start, end, and now the then loop kicks in, and it's like, okay, I need to pick up a task. So it looks at the state, and it's like, oh, I have a micro task created on here. So I'm going to run this one. So we have start, end, promise end, and then timeout. Yeah, start, end, promise, then, timeout. Now let's.
So I have a question. Is it possible to trigger a Stack Overflow by having recursive set timeouts trigger each other. It's like if I do like a function that it's like queue set timeout, and then inside that function I call queue set timeout, comma 0, can I trigger Stack Overflow doing that?
As far as I guess, as far as I guess, no, right?
What do you guys think? If I do, like, imagine, like, just like that set timeout, like, imagine that I create a function that is queue set timeout. Then that function is an error function that returns a set timeout. And inside the set timeout calls queue set timeout, comma 0. And then I call that. What do you guys think will happen? Will that trigger Stack Overflow?
I don't think that it will, because as per my understanding, how execution will work is the event loop will check if there is anything to execute in the stack, in the call stack. So if there's nothing, then it will go to the queues.
That is correct. That is correct.
So now in the queue, we have a set timeout. So it will pull it out of the queue and put it in the call stack. Now in the call stack, we'll execute it. And this will again call another set timeout. So it will again be put it back in the queue.
So next question, because I think this is important to understand the difference between macro task and micro task. So a macro task, because every time it gets executed, every time it gets queued, you wait for the queue of tasks that are supposed to happen synchronously to be cleared.
Yeah.
It cannot trigger a Stack Overflow,
Yeah.
right? Now, imagine that we do the exact same thing, but instead with a set timeout, we do a promise then with a micro task. Would that trigger a Stack Overflow?
As per my understanding, I expect the same behavior to not.
No, that is incorrect.
Okay.
That is what most people think. If you try to do the same thing, well, I know that I tried, but I think I know. If you try to do the same thing with a micro task, that would trigger a Stack Overflow. The reason, and this is, please keep this in mind, the reason is that the macro task waits for all the synchronous tasks that are supposed to happen in this macro task to be cleared. What the micro task does is it kind of squishes in, right? It skips the list of asynchronous. That's why, remember that Victor said, like, macro tasks are triggered by I/O, like things that happen outside, but micro tasks are like these kind of little things that they squish themselves into the list of synchronous things that will happen in the end of the current list of synchronous things that are happening for this task. But that's where they are called micro tasks, because they put themselves into the current task. So if you try to do the exact same thing recursively, you're going to get a Stack Overflow. Does that make sense? And I think that this can help you understand why in this example, promise resolve gets locked before the set timeout, right? Like the set timeout got registered before, but somehow what got registered by the promise resolve got locked before. Why is that? Because it gets squished into the list of tasks of the current macro task that it's currently running. Yeah. So that's why one can trigger Stack Overflow and the other one can't. But maybe later, I don't want to, I have hijacked Victor's a little bit too much, but I thought that it was a good moment to explain that. But maybe later I can give you a few more examples and draw it in the board. But yeah, just keep it in mind. Like this is the main like macro tasks are like these reactions that we have, like a queue of things that are happening. So every time that there's one after the other, but like micro tasks are like these cheaters that they squish themselves in to the current list of actions that need to happen. Yeah. Sorry, I'll try to explain it better later.
I want to actually check what happens if I do a time bomb of like.
You don't believe me?
No, I do believe.
You don't believe me? Okay, try it.
So
let's do it.
No, because like this is also what I thought, right? Like in the case of like queuing macro task, it will not get an overflow because essentially it's just like starting from a new sort of like context. But the train of thought I had now saying like, okay, I want to really try it is because of closures, right? Like in JavaScript, we have closures, and when you run a function inside the function, essentially that function can access the closure that's inside it. So my question was like, what's going to happen if I do something like crazy? So let's give this a try. What I want to do is I don't know how to do it so that I can. Sure. Yeah, sure, yeah.
It will be super quick. Can you hold them like just one more?
Yes.
So what I was trying to explain, hopefully now it will make sense, is that if we do set timeout, right? Like let's compare these two, right? Like set timeout, oh, you have this.
No, it's just like on the console.
Yeah, not like the keyboard I was talking. Right, like if we do this, right? Yeah. I'm not retarded. I'm not just used to this layout. Here. Nice. I do run. Well, maybe it's better if I'm going to call it run 2 just in case I cannot. I'm going to do console.count run. This is going to, like it's going to go bananas, but it won't blow up. Motherfucker.
Arrow up.
Count.
Console count.
Sorry. I'm going to call it 2 just in case, because I already have one. Yeah. Does that make sense? So if I run this one, run 2. You see, it's going like it's going crazy, right? It's like running nonstop, but it won't blow up. You see, because of what we explained before, it's keep queuing, but like there's never going to be a Stack Overflow. Like it'll go here forever, like until console count maybe stops working because whatever. Like it just doesn't blow up, right? However, if we and also interesting, you'll notice that if I do hard refresh, it's able to quit quickly, and it like the app is responsive, like the window is responsive, right? However, if we try to do the exact same thing, but if instead of using a macro task, we use a micro task, that should do, right? Yeah.
Promise then, promise resolve, maybe.
Oh, sorry, promise resolve, I meant. So, I know, but promise resolve, then.
Yeah.
Promise resolve, then, sorry. Yeah? Does that make sense? Now, this is not bueno in theory. You see that it's starting to go slow. Eventually, like now, boom, and it blew up. You see that it blew up? And it's unresponsive. Right? Like it, we cannot see it, but like, well, what I'm trying, even if we try to do, it blew up basically. Like I cannot even do
A refresh. Yeah.
a refresh. Like it just, believe me, this blows up, right? Like this is, I mean, you see many, but it eventually blows up. Anyways.
And now I have to restart my laptop.
Sorry. No, just close these.
Kidding.
Just close these.
Yeah.
Like if you can. Yeah. Sorry.
Microphone. What I wanted to try, like, also like, because what I wanted to try was related to this, but was more a question like, oh, I can create a closure, and then, if I keep making like a recursive call that creates closures, then this will blow up in memory. But then I thought that this is not actually possible, right? Because, sorry? No, like, what I thought is like, at some point, like, right, like, the thing is, when I was trying to say, like, how can I write this? I cannot really write this, because if I create like a function that, that does like, well, what we had before, right? Run, like I can create here a closure, and it's like, okay, I'm going to create a value 0, and then I'll do set timeout, and here I'll do b++, and then run. But what's happening here is that this run, it's just like creating a new closure, that's fine. But this over here, once it finishes, this V is dead now. So the garbage collector can take it away. And there's no way I can like make some sort of like recursive call that essentially keeps creating closures for each one of them. If you see what I mean. Maybe if I had here some sort of callback, I could like, I don't know, B++. Maybe this. I mean, let's see what happens. Yeah, and I'll do that. But it should run, and I need to pass in a callback. Oh, I need to console log. Yeah. Console count run. Oh. Sorry about that. Count now. Okay. Nah. Still running. And yeah, something like that's, oh, damn. Well, you can see that this thing is still running and it's not
Yeah.
doing that.
So one thing I wanted to point out while I'm explaining this, like you guys may be thinking like, why are these people wasting all this time explaining these things? It's because like, if you have to work with JavaScript or TypeScript, whatever, like it's very important that you understand the primitives that are used behind the scenes for dealing with concurrency. Because it doesn't matter if you're using observables, if you're using effects, if you're using runes, if you're using like whatever construct that it's built, they all behind the scenes work with microtasks and microtasks and macrotasks. So there are only these three different kind of things that can happen in JavaScript: synchronous code and asynchronous code. And inside asynchronous code, there are these two different kinds of asynchronicity. So if you know that behind the scenes, one is using one or the other, right? That can really help you at understanding the different kinds of like race conditions that you can put yourself in and how to prevent them from happening. Whichever primitive you use is like knowing these things, we really think that can really help you, right? Does that make sense?
Okay, so after this intermezzo, we have another example of more stuff to figure out what is the order of things. So what do we have here? So we have like some promise somewhere else, that's fetching something, and after a while we get the result, which is 1, 2, 3. Then we have also a function that does stuff, and the code what it does is like, first it sets the timeout for timeout, then does promise resolve, then promise then, and then does do stuff. So we look at what the do stuff does. So do stuff, it's an asynchronous function that first calls do stuff, and then awaits the promise somewhere else, and lastly, consoles log result of that promise. So what's going to be the log of this one? And I have to think by myself as well. Mm-hmm.
Someone is taking a guess.
I'm guessing the second resolve off the set timeout first.
Sorry.
No.
What? Sorry.
The promise.resolve.then with the console.log promise.then is a microtask. Oh, okay. Okay.
Yeah.
Okay, give it a try. So it's do stuff, and then yeah, and then promise dot then, and then result of the value 123, and then you get your timeout. Yes.
Yes.
Oh.
Oh, let me check, but like because it's yeah. So why is this then? right? Like in this exercise, what I try to trick with is like, well, the promise there has already solved, right? Like we have like promise resolved 1, 2, 3, and it's now solved, right? So the trick I wanted to do here a bit is like, you know, here we have like another promise resolved then, but essentially like this has resolved before, right? So it sounds like this thing should run quicker in some sort of way. So that, like this is what I was trying to trick you. But remember that, so okay, let's go one step at a time. So it runs all of this, nothing has happened yet because it's only queuing stuff and declaring stuff. Then it runs do stuff synchronously, which consoles log do stuff. We have the first one. But then when we get here, we have an await. And remember what I said, that, you know, what triggers the microtask is the await and the then, right? So this await is now enqueuing a new microtask. Like, never mind that this promise has already resolved, like before. Now this await is enqueuing a microtask. So what we had in the queue before, it was a macro task for this one and a micro task for this one. Yes? And now this one gets enqueued just like below as a new micro task below the one that we had. So now when the event loop kicks in, looks like, oh, I have 2 micro tasks in my queue. So first resolve this one, and then it will call promise then. Yeah. And then takes a look at the micro task queue again and says, oh, I have this one, and then it will resolve this one. And then we have result 1, 2, 3. And lastly, we have the macro task. Yeah. So, and lastly, there's another thing that we need to watch out, which is like this code is absolutely synchronous. Okay, here we don't have any synchronicity, even though like it looks like we have a callback, but this callback is also synchronous, right? And this code has a bug. Yeah. So we have a create counter that, you know, this counter is just like increments counts 1 by 1, and then like consoles log the current value. So it, you know, you call it once, and then you have incremented to 1, incremented to 2, incremented to 3, and so on. But like later on, someone said like, oh, I need to know when someone calls this for the first time, and then passes in like, okay, I'm just like going to provide a callback so that on the first increment, I'm just going to call this callback. Yeah. So we have something called reentrant calls, which is which they are nasty when you get bugs like this, which is what happens if someone then creates a counter that wants to, you know, whenever it's called for the first time, it will increment another time. Yeah. Then what, like we would expect like essentially to see like you call increment and then you see incremented to 1 and then incremented to 2. Right? This is what we would expect. It's like, well, I call increment, then I will have this, and then, you know, I'll increment again, and then I'll have by 2, and it doesn't like overflow or whatever. Like it just like does it for the first one. But the problem here is that if we run this, that's unfortunate. Yeah. Yeah. Incremented to 2, incremented to 2. What happened here? So let's see. Like like when you actually like go line by line, then you say like, oh yeah, it actually makes sense, right? So I'm calling increment. So increment, I'm calling like this function the first time, and then it does count plus plus. Nice. So count is equal to 1, yeah. So I'm calling on first increment. So what do I do on first increment? I call increment. And then increment comes back here again, and then does count plus plus, which puts the counter to 2, right? And then it's like count is equal to 1. No, then I'm incremented to 2, right? And then this function finishes, which means that it comes back here, that it has already incremented. And then this function finishes, which comes back to here. And then it continues, and it says incremented to 2, because it has already incremented the value. Yeah, this is also like the callback hell. So But anyway, like when you work like with asynchronous code, this is what I meant by mixing asynchronous and synchronous code is even harder, because you try to do stuff like that, and then you don't think about reentrant calls. And reentrant calls happen synchronously, essentially. It's like something that you thought like, oh, like this is a callback, so like this is going to be like asynchronous, and everything will be fine, because if this was asynchronous, right, this would be pushed into a macro task or a micro task or whatever, and then we would have incremented to 1, and then the macro task runs, and then we have the new value. Yeah. But because it's synchronous, like it's like one thing is happening after the other, and if you're thinking asynchronously and you forgot about what's happened synchronously, then you might run into problems like that. Yeah. So it's hard. So the key take awaits. So yeah, like what do we take from all of this? What we have seen. So first of all, like when like this thing, like if you have a synchronous block, like this synchronous block is not interrupted, there's nothing else running besides it. Like one instruction runs after the other, and you're guaranteed that there's no other instruction running and like changing your state or whatever. Okay. Then the other thing is like, well, taking into consideration how the event loop works, and this is like maybe like it can sound like a bit low level, but it's fundamental to understand how this works when you're dealing with asynchronous code. Okay, so let's dive async. So now we're going full async. So before we start all of that, we always have concepts and stuff and a bit like historical context and whatnot. But so yeah, like when working async, like we have two ways of working. So we have what's called pull interactions and push interactions. Okay, so when we have pull interactions is when we want to fetch the value and at one specific point, and then we get the value back, and like this is just like when we fetch, right? So imagine that, I don't know, we want to watch like the value of account and how it changes and so on. So we could have like something like that theoretically, right? Like while we keep watching, then we will loop over here, and then we fetch the value of some account and get the value. And if the value has changed, then we say, oh, there's a new value, and it was this one. And then we await some time, here 1 second, and then come back, right? So at this point, we are pulling some value. Yeah. We have another way of working, which is called push. So push is telling the producer of those values, telling him like, hey, I'm interested in this account. And now when this producer knows that the value has changed, it will notify us. So in this case, we have query system account, watch value of this account, and then we can subscribe. So we're telling the producer, hey, every time that the value of this account changes, please notify me. And then we get the value back. Yeah, this is like two valid ways of working with the same data, right? Like you will see some applications that deal with asynchronous code only by pulling, so fetching information whenever they want, or like letting the user like click refresh. But then you also have the push, which then usually you require some sort of like communication from the server, like a WebSocket and stuff like that. To get the updates. And usually, like when we deal with real-time data, it's usually better to use this thing, because otherwise, like with real-time data, essentially it's like every second, every millisecond, you would have to be pulling up like, hey, is there new information? No, there's not. Hey, is there new information? No, there is not. So this would be extremely inefficient. So this is why, it's at some point it becomes a bit better of telling the server, hey, whenever this thing changes, please notify me. And this way I don't have to be pulling, essentially. So yeah, pull is when the consumer decides when to get the value, and push is when the producer notifies of this new value that's coming through. So now let's think about what is pull and push in terms of the JSON RPC spec, right? So chain head events, is that pull or is it that push? How do we get the events from the chain head? Like when there's a new block, when there's a finalized block, when the best block has changed, all of that. in which category does it fall? It's push, yeah? Because it's the server that is telling us, hey, there's a new block, right? But on operations, it's pull, right? It's like, hey, I want to know what is the value of this storage value, right? So chain head is push, operations is push pull. Why is that? Why have I put this thing here? Like theoretically, right? Like it's like we have like these two different ways of looking at it, right? So from a high level, it's like, oh, I want to query this storage value. I want to query this body, right? I want to get the body from that. So it's like I want to pull it. From a high level perspective, this is pulling, yeah? But if we look at the actual spec, what happens is that we start an operation to get the body, and then we get just back a result of like, hey, here's your operation ID. And this, hey, this is your operation ID, means that later on, the server is going to push that value to us with that operation ID. And it will tell us, hey, I now have the body, here's the body, right? The body has not changed, but this is essentially a push action. So this is why it's like, well, there's a bit of pull and push, like depend on how you look at it.
Hey, Emiliano here. It's considered a push because since it is a WebSocket, you are like a pull will be, for example, if it's HTTP and you are in one TCP connection that closes when you receive the response. And in this scenario, since the TCP connection is always open because we're in WebSockets, you just pull because it's the same channel.
So more or less, right? This is the thing that I'm doing here. So it's like, it's kind of both, depending on at which level you look at it, right? Like even like if you look at TCP level, then everything is essentially pushed because the server is sending a packet at some point, and this is some sort of like, well, this is like the server is pushing some value. That's right. But like from fetch, from a high level perspective, it's a pull mechanism because it's like I want to get this value, and then I get the promise, and the promise resolves, and I get the value, right? There's no way with a promise to make the server return many values one after the other as they change. You have to go to the server and ask him, hey, is there any value? Here it is. Hey, is there any value? Here it is, and so on, right?
So when you say that is in a high level is pull, is because in PAPI implementation that you await like in some way for the polling.
In terms of PAPI, yeah, but like you have to think of like a pull interaction as a way of like the consumer, which is your dApp, is the one that decides, now I want to get the value, right? This is a pull interaction. Whereas a push is the dApp just tells like, hey, I'm interested in changes on this one. And the server is the one that, the producer is the one that sends messages as they come.
Okay, thanks.
But if we look at the low level, right? Like you made a good observation, which is that WebSockets actually facilitate push notifications. That is true. However, conceptually speaking, over a WebSocket, right? Like if you, for instance, if you look at most operations inside Chainhead, they are what Victor explained, which is their pull-push. However, there is one in particular that, in my opinion, should be considered pull only, which is the one for getting the header. The reason for that is that the one for getting the header, you just send a request, a normal gSnarPC request, and what you get directly is the reply, right? So even if it's over the WebSocket, that operation is pull. And the fact that it happens over WebSocket is just an implementation detail. What makes the other ones push is the fact that when you start the operation, the server is giving you an opaque ID so that you track the events that you are going to receive, because you can receive several events. On another note, it is very useful to have this operation ID because it allows us to cancel for these operations when they are no longer needed. So because of, like, probably he will get there later, but like a small dot and the spec guarantees us to always have available 6 operation slots. So we handle that behind the scenes, right? Like if all the slots are full, then we wait for one of the slots to empty and you don't have to worry about that. However, if when you are using the library, you are mindful of this, and whenever you are no longer requiring certain data, you cancel the operation, being because you use observables or because you use overtotal promises, we will actually cancel that operation, and the other operations are going to run faster. You're freeing you're freeing the client from unnecessary operations, basically. Does that make sense? And the only reason why this is not needed in the header is because, like, the header, it's always the light client always has it. Like Chainhead is specifically thought for the light client, even if RPC servers also implement it. And the header is something that it's pretty much always in memory, so there is no need to cancel anything. Does that make sense? There's no need to free resources because it's pretty much it's a request reply. Does it make sense? Sorry.
Yep. Lastly, though, there's a bit more than that, right? Because if we go even a higher level up, then it becomes push again, right? So it's like, oh, give me this this body, whatever. Then this is a pull, like from a high level perspective. But PAPI does something else, which is like you have watch storage or watch entries, right? And when we do watch entries, what's happening on a level below, it's actually pull. Like PAPI, what all it's doing is like, oh, when we have a new block, now I'm going to see if there are differences. So now it pulls like the closest descendant Merkle value and so on, so that it can change if there were any changes on that tree. And if there were, then it does another pull of like, okay, now give me the storage values of those ones. And then I'm going to give it to you. But from the perspective of the dApp developer, this is actually push, because it's like, okay, give me the entries of these storage values when they change, right? So depending on the level that you're looking at, essentially, you have like different mechanisms of like pull and push and whatever. So when we want to work with pull and push, we have different tools for that. So well, push is always asynchronous. Pull can be synchronous or asynchronous. What I mean with that is that, so right, like imagine that you don't have a network request, right? But you have like a in-memory database or something like that. You can make a pull operation of like, hey, give me the value of this thing, and maybe it has it in cache, and then it gets resolved synchronously. Push can only be asynchronous, right? Because it's like, give me whenever this thing changes. So before we had any tooling, the way that we have to work with all of these things is with callbacks, right? So here, like, we have like 2 different things, and actually both of them are valid for push and pull. But essentially, it's like, okay, give me the value of this account, and when you have it, just call me this function over here, either with a result or an error, and then it will. We can just do stuff with that. Or you could do even, like, there are other APIs that, separate the values from the errors. What we had then, because you can imagine that the problem here is that this is fine. Like, give me the value of this account. But now if we want to get or let's say that this is like pseudo key. So first you got the key of the pseudo, and now you want to know its balance, right? So you would have to wrap this thing inside another callback, right? And then things get like extremely complex. So what they came up with for dealing with asynchronous code is like promises, yeah? So promises, they are technically still using callbacks, right? When you use a promise, you do this like promise.then, and then you pass in a callback. So you're still using callbacks. But the key difference with that is that now it's a common interface. And now everyone can use promises, and more importantly, they are composable, right? So you can take many promises, put them together in a promise all, make them resolve all at the same time, and so on. And even better, later in 2017, we had like an upgrade to the language, which introduced async await. So now you can work with promises as if it was like synchronous code, which now works great. And this works great for fetch operations because like a promise, it's something that, resolves one value. So if you want to fetch something, then you call fetch, and here's my address that I want to fetch, and then I get back a promise, and this promise resolves. But for push, right? What can do we have any tool for push? We're still in this limbo, okay? So there's something called async generators, but this is not actually what we want, but it would kind of look like that, right? So imagine that we have something that's called, we have this theoretical AP like PAPI in a parallel universe that works with async generators, and you have a watch value, and this gives you an account. And async generators are functions that return promises, okay? So you could do something like that for await. This is valid JavaScript. What this thing is telling is like, okay, for each of these promise that this thing is returning, you await that promise and then get the value and console log it. Yeah. So, like from a like you could think like, oh, like then this is solved because like in here, every time that we get a new value, we will receive this here. But that's not really true because all of this thing is doing is just like pulling, right? Like every single time that this loops through, this calls this function that creates a new promise that this promise will resolve. So this is not push. This is still pulling values. And also, like async generators are extremely hard to work with. I really don't recommend them. You had something to say? Yeah. So, and there's another problem here is, how do you cancel this? Right? Like, remember, like when we are dealing with a push mechanism, we're telling a producer like, hey, I'm interested with this. Please come back when you have more values, right? But you always have the mechanism of telling the producer of like, hey, I'm no longer interested in that. Please don't notify me anymore, right? When we're in here doing this, how do we cancel that? Because when we keep getting values, that's okay. But then at some point, it's going to want to do a count. This is returning a promise, and now we are awaiting that promise. What do we do now? How do we cancel that promise? We just cannot cancel, right? Like we're stuck here. We cannot run anything that tells this producer of like, hey, I'm done. Don't notify me anymore. And then I'm, maybe I can put a flag of like the same that we did with React. Like I can put here a flag of like let is canceled is equal to false, and then here check if it's canceled or not. But I'm not telling the producer like, hey, I'm not interested with that anymore. Please just forget about it, right? So again, like this is not the best thing. So what do we have? Well, we have observables. Okay, so you can think of an observable like a promise, but for multiple values, right? So it's essentially like a data structure, or however you want to call it, that instead of just giving you one value, it will just give you multiple values during the time, okay, for as long as you want. And the concept is more or less the same thing. Like what it tries to do is remove this callback hell by having a common interface that everyone can use, and it's also very composable with each other. And another feature it has is that you can convert an observable into a promise and a promise into an observable. Of course, like there are trade-offs. Like if you take an observable and turn it into a promise, then you have to decide what value do you want to get from that observable, because the observable can return more than one value. So you can say like, well, I want the first value that is returned, or the last value, or like all of the values into an array. I don't know. You can do whatever with that. And the good thing is that it's in TC39 stage 1. So TC39 is the organism that makes JavaScript specifications and turns it upwards. So stage 1, it means that it's in consideration, so it's there. I mean, yeah, for a few years. So like this is big copium. Okay, like I'm not really sure if observables will be part of like the official JavaScript spec, but meanwhile we have a library called dApps that that deals with observables, and I know that I really like this. Like there are other libraries that use observables and so on, but React.js has a nice community, and it's one of them essentially. So instead of like the slides, I'll probably go live code here. So let's work with React.js, and I'm here on the getting started with Papi thing, so that I can commit stuff if you want. So I'm installing first the package React.js because we were gonna play with that, and import from React.js. I'm going to remove all of the Papi stuff for the time being. Oh, I was too hard on this. Okay, so from React.js we can just get the observable, and let's create an observable, right? As if it was a promise. So const my observable we will play with. By the way, usually you will see me put like a $sign at the end of that. This is just a convention that React.js users have, that every observable ends with a $. Yeah, it's a convention that you can follow, you can ignore. But I'm used to put every observable with $. It just means that this is a stream, so you have an observable here, and you can just use it. So we are gonna create an observable of numbers. So far, this is very similar to a promise. Oops, try ver. Yeah, no, it's a subscriber. Anyway, so I'm gonna put this like so. So what we have so far is we have created an observable that now we can send values to this subscriber. So this will be our producer code. Okay. So now when someone subscribes to this, is essentially like it's doing a push. Right? Like when someone comes here and says like my observable subscribe, and here we'll receive values, it's like, hey, I'm interested in the values of this observable. So now this is the producer, and the producer receives this particular subscriber. So it's like, hey, you have a new one that's interested in whatever you have to say, right? So what I'm going to do here is that this observable will just give the numbers from 1 to 10, 1 second at a time, okay? So what I'm going to do is like let number it's 0, and then set interval every, let's not make it that slow. I'll do it every 200 milliseconds, so it's a bit faster. And now every time that we have, we want to increment the number, so we do number plus plus. And maybe what we can do here is like say, well, first off, I'm gonna tell this subscriber, hey, here's my number. So I'm going to call a function called next to tell it, hey, here's a new number. And then here, every time that we increment the number, we tell our subscriber, hey, we have a new value for this number. Okay, and now we need an exit condition because I only want to send 10 values. So at some point here, what I'm going to do is I need to cancel this interval. So once I can this interval. So now I can do if the number is 10. Well, then I'm sending 11, but that's fine. If the number is 10, then I will first clear interval so that I don't produce more numbers of this token. And then I'm also telling my subscriber, hey, I am done, right? I will not send you any other number. So now when we come here, we can do my observable, subscribe, and here we receive each one of the numbers and console log. Maybe I can do it in a console instead of like the opening in a browser. I think this would be better. So I'll create one file here of like rxjs tests. So, yes, and I will move all of that there. Okay, so now I can run this with Bun or Node, maybe if you have like TypeScript and support and so on, but rxjs test. Rxjs. This is one of them. Because I missed to put the thing. And we have our number 0 to 10, right? Now, what you see here is like a push interaction, right? This, in here, we're telling like my observable, hey, I'm interested in receiving numbers. And now our producer is like incrementing the numbers. And when the number changes, it just tells us like, hey, here's a new number, right? If you try to do this like with a pull mechanism, then you would have like a more complex scenario, right? Because then in here you would be pulling values from the producer of like, hey, is there a new number yet? No, there's not, and so on. And what would happen if you have if the pulling takes longer than the numbers are getting generated, then you might have like skipped values and so on. So that's not really good. Now we have that. Something that we're missing here is a cancellation mechanism. Yeah. So how do we cancel an observable? When we subscribe to an observable, we receive a subscription. And then in this subscription, we can say, well, actually, let's do it here. So if the result is 5, then subscription unsubscribe. Now, this is not complete yet, okay? But this apparently will work. But did you see that? Right? I run it again, and I actually will run it in, I'll do just 3 numbers, so it's a bit more apparent. So I run this thing, and it does 0, 1, 2, 3, 1, complete. You know what happened here? So what happened here is that this subscription has ended, indeed, after 3, so we don't receive anything else. But this interval right here is still running. So this is why the process doesn't end, because this is running. So this will keep notifying a subscriber that's not longer there. Like rxjs deals with this so that it doesn't blow up. But this is not doing anything. So what you can do here is when you create an observable, you can return a function that's like a cleanup function. And here you can say like, well, whenever someone unsubscribes, then I'm just going to clear my token. And now it was immediate, yeah? So it went like 1, 2, 3, boom, done. This is very basic and all. But let's see how we can go about this. Is there any questions so far? Yeah?
I repeat, sorry. What did you call 2 times the subscriber.next? Like inside the set interval and outside?
Yeah, well, because I wanted to give like the initial value. Yes.
Okay.
So look, like this is number equal to 0. Then I'm setting here an interval, but this will run after 200 milliseconds. And so it will run after a while. So here I'm saying like, well, the first value is this one. So I'm just telling my subscriber that, and then then this will keep updating.
Actually, that's a pretty good question, because if you go down, I mean, I don't want to trick you, but like that value gets emitted synchronously. So in the moment that you subscribe, gets emitted synchronously, which means that if Victor goes down in the code, and where we have that, if res equals 3, if instead of equals 3, he writes equals 0, then you're going to get a runtime error. because subscription, the variable, has not yet been finished to declare. Because that code got, when you subscribe, remember, it's like the promise that gets executed eagerly. When you subscribe, it's like, okay, now, right? So because you got that value emitted synchronously, the subscription that you have in line 25 still doesn't exist. It's being created. So that will blow up.
Let's do this live. Yeah. So what I've done here is like I have created this thing, right? Like I subscribe to this, and then I console log hello. Okay. So this is one of these things that, you know, dealing with asynchronous code and synchronous code makes it harder, because when you look at this code, you say like, oh, okay, like this will happen asynchronously, so it's fine, and then here I will have hello, right? So at first sight, you would think, first I will see hello, and then I will see each of the values as they come through, right? But what happens here is that I've made a producer that immediately will send me a value. So we have 0, then hello, then 1, 2, 3. So what he was saying is that if here we have a res is equal to 0, and we do subscription and subscribe, what's going to happen? Cannot access subscription before initialization. And what's happening here is that this function over here is running synchronously because our producer has called us synchronously. So when we come here, res is equal to 0, and then we grab subscription, but we didn't let JavaScript to, you know, return the result of subscribe yet, because it's calling subscribe. Subscribe is going through RxJS. RxJS is doing all of that, and now subscriber next comes here, and now subscription is not yet, it doesn't have a value just yet. So this is one of the pain points that like at the last I have them, but yeah.
And if we remove the 0, that subscriber next, they would then wait for the subscription or just crash?
Yep. Well, the only thing is that I need a 0, right? So what I'll do is this, so that, you know, it starts with the 0. This works fine. Yeah. And this is because now this 0 is asynchronous. Yeah. The only problem was this one, that because this subscriber was notified synchronously, then this thing also runs synchronously. So when we get here, we didn't even have time to get this subscription. So this is a bit harder to solve. This is more advanced stuff. Like essentially, what you can do, I think, it's like create a subscriber, but it's even now like I think that there's a better way of doing this. But the way that you could fix this is first creating the subscriber and say like on next, and then I receive a value which is a number. So on next, I'm doing this. What am I getting all of now? Oh, because I need to pass, like this is advanced. This is advanced RxJS. Like in here, you need to pass all of the properties. So it's a bit. You only do this like when you're like working like deeply with stuff, because usually we work in a higher level and we don't need to deal with all of that. Otherwise, you can also do like the hack of, you know, putting flags and that, but that's not really the option. Okay, something else I wanted to show with this, and I'm just keeping, this is fine, is without unsubscribing now, so I don't need any of that, is the concept of hot and cold observables. So something that I said before is that what RxJS gives you here is whenever you get a new subscriber. Yeah, so every time that someone subscribes to your observable, you will get a new call of this function with a new subscriber of like, this is your consumer that's interested in your values. So now you would start again, right? So if I come here and I do my observable subscribe, then I do set timeout. And then here I do after 500 milliseconds, I'm starting a new subscriber, and call this subscriber 2, and then I'm calling this subscriber 1. If you're not familiar how observables work, you would expect that, okay, like this observable is like emitting values, and this is getting values one by one, so 0, 1, 2, 3. And then when this one comes, it's subscribing from the same observable. So you would expect that it will receive the same values, right? But what's going to happen? Ooh, so many stuff. Is that subscriber 1 is receiving 0, 1, 2, but then subscriber 2 begins and it's receiving 0. And subscriber 1 is receiving 3, and subscriber 2 is receiving 1. You see? So each one of these subscribers essentially have their own state. You see? And at some point, even 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, and 2, 2, 2. It could even happen that you don't have them like in order. Like you could have like maybe 2 sub 2 and 1 sub 1 and so on. So what's going on here is exactly what I explained, right? Like you have to think like of observables of a producer receiving subscribers, right? Receiving consumers, and then for each one of these consumers, you can create here your piece of state for that specific one. So each one of them will have their own number, and the number will increase individually for each one of them. That's surprising? Is that okay? Can we attach the first one? Yes. Now it's a bit more tricky, right? Because if we want to do that, then we need to have some sort of shared state between each one of the consumers. But this is a great question. And how do we do that? That's also a bit advanced, but let's give it a shot. So something that that RxJS exports here is called subject. And a subject is a way of managing subscriptions and everything so that you can share some piece of state with many people. So the only thing is that I want to now separate, because otherwise it will look a bit hard to understand. But consumer. So remember, like what you always have here is like one particular consumer, right? So now in here, we're generating the values from within this function. But if we want to share it with other stuff, we need to bring it out. Yeah. So the producer, you can imagine that then what it will do is like, well, I have my numbers here. So I'm going to get all of this, put it here. Let me close because now it has got my indentation. And so now here I have my list of numbers, and I'm just incrementing my numbers. And so far, like we don't have any subscriber here. And then once we're here, we just like clear ourselves, and now we're done, right? So now the way that we have of sharing this is like, well, in here, now we need to access this. How do we do that? We can start like again with subscriber next number, but now we need a way of connecting the subscriber with the value of the number. So this is where the subject comes in, because subject helps us massively with that. We have subject, it's new subject a number, and now this is both an observable and a subscriber at the same time. So essentially, it's an object that we can push values to. So we can do subject.next, and we can give him like, here's a new value, here's a new value, here's a new value. But no one is listening, right? What we can do also is subject.subscribe. So now we're telling, okay, whenever someone pushes a value to the subject, please call me. Okay, with this data structure, we can do this. So we come here and say like, every time that the number changes, I'm going to do subject.next subject and number. And here, I'm going to do subject.complete. Complete. So we're done. And now inside my observable, first I'm passing the current number. And then what I can do is subscribe to this subject. So subscribe to that. And I can even pass just like directly the subscriber if I want. Right? Because it's like, And I'm telling this subject, hey, this subscriber over here is interested in receiving your values. Or if you want to make it explicit, then you can still do my new number, subscriber, then next new number. And now if I run this, now it works as we expect. Yeah. So we have subscription 1, 0, 1, 2. Now subscription 2 comes, and now it's value 2. And now every time that the value changes, both subscribers will get the same value. Okay. Now this might look a bit messy, but it gets better. Don't worry. When you're working with observables, you usually don't have to work with this. But again, it's important to understand a bit how they work under the hood before we can do more stuff with them. Yeah, well, this is what we've seen, right? You want to subscribe to an observable to start receiving values, you just subscribe to it. Now there's another one which it's a bit more complete, and usually I think it's the more recommended way, which is that the observables also notify you when there was an error and when the observable completes. So you can pass an object and then with next error complete, and you can receive each one of these. The only thing to notice, which is really important, is that an observable, when it errors, it dies. Okay, so you cannot have an observable that emits values and errors because it's oh, I'm having here a subscription, and when I want to know when an error happens, I'm just receiving the error, and then I'm expecting to receive more values. No, that's not possible. If an observable emits an error, then this observable will not emit anything else. You have to subscribe to it again, and then it will produce more values probably. Okay, so if you have some sort of interaction that deals with errors that are not fatal, I don't know how it's called, but then it's probably better to just model your observables so that the value indicates if this is a new value or if it's an error, right? Because if it's something that it's part of the business logic, then the error is more meant of oh, there was a connection error, for instance, so you will not get any other value from that, and then it kills it. And same thing for complete. If it completes, it means that this observable has completed. You will not receive anything else, so it dies. Now we have seen how to create an observable and all of that, but we haven't gotten into the interesting part of the observables. It's just that how do we compose them together and how do we create observables from others? So there's this bunch of functions that you don't have to implement them yourself. It's RxJS has a lot of functions of this sort, which are called operators. Okay. So an operator is a function that takes in an observable and returns another one. And this observable that it returns has more stuff to it. So for instance, here we have an observable that gives it some numbers. And now you can create another observable called multiplied by 2 that basically uses this operator over here, which is called map, that maps each value and multiplies it by 2. Yeah. So how do we read this? Because this looks a bit convoluted, but you will see that later. It gets a bit easier. Okay. So when you call this function map and you pass in this callback, I'm just saying okay, this is a map that will multiply its value by 2. If we look here, we can see that map is this function that takes in this map function. So we are capturing that, and now we are returning another function, which is this one. But this function has this callback captured, so it sort of remembers it's this one, yeah. And now what RxJS is doing here when you do pipe is basically passing this observable to this function over here. So this is why I have this comment here. So this thing is the same as calling the map function and then passing in multiplied by 2. It looks very convoluted, but this makes a lot of sense as we keep going through. Okay, so what's happening here is that now this multiplied by 2 observable will be the result of this function that is called. So it will be a new observable where it will subscribe to the source, which in this case is this observable. And then every time that it gets a value, it will call subscriber next and that. Okay, so I'll copy this. Copy here. And also, like as a user, you usually don't need to use new observable. Like we have a lot of functions that do everything for us. For instance, the observable that we had before that creates one number every second, we have a function called interval. So in here, we can say, well, this observable is just interval. So call me every 200 milliseconds. And this will give me an observable of number, which is like each one of the interactions, basically. Right? So and I do multiply by 2 subscribe result, and then so log result. So we're receiving the values multiplied by 2. Does that make sense? You can see what's happening here, right? So what I'm doing here is the same as if I did essentially this. So const multiplied by 2 is equal to this new observable. And well, here I'm using like generics and whatnot, but this is observable of number. And then the source is this, sorry, it's the interval of 200. And the map function is what I had here, which is b times 2. So, sorry, I just think that. Right. I'm basically doing this, but like in a more, you could say like complex way. But the cool thing is that this map function that I have implemented here is also implemented by RxJS. So I can do map interval. And now I have this, and I can do, sorry. So I can do const multiplied by 2 is equal to interval of every second. And then I'm just passing map, and I'm multiplying each value by 2. Right. Well, it's often better to see it this way, but prettier is, well, now it's slow because I have put every second, but now you can see that it's doing this, right? So you see how this is looks convoluted, but it's not that much. So let's say that now I want to do the same thing, because this will run forever. Right in here, if I put 200 without formatting. So you see like it's doing 0, 2, 4, 6, and so on, it goes forever. So what I can do is what I did before of like saying, oh, I just want to have, you know, I just want 10 values. I don't want more than that. So I can just do take, and again, I have imported from RxJS, and I say I only want 10 values out of this observable. And then when I run it, I got 10 values. Now it ended at 18 because we also have the 0. Yeah, but otherwise it would be 20, which is 10 times 2. So if we go back here, yeah, this is exactly what I explained now. And now, like operators, I said, like there's an endless list of things that are already done, so you don't need to do too much. So here are like 2 very useful resources. I will post them in Discord in a moment. But here is like the official documentation of all of the, where is that? With all of the operators, and you can see like there's creation operators. For instance, here we have interval, right? So this is a function that creates an observable that emits 1 value at a time. Then we have other operators that, merge 2 observables together. So you have 2 different observables, and you want to create one that emits the value of both of them. You have merge. Transformation observables. So here we have map, right? So this transforms one observable into other. filtering observables. So you can also, filter is like the easiest one, right? Of like, I have this observable that's emitting values, and I want to filter the values that are greater than 10. Then you can use this operator, and it will give you another observable that has all of those values filtered, and so on. And another one, because like in this one, if we go at map, like this is like the official API, and here you have some diagrams and so on. But another resource that often helps for me is this thing, and they have changed the pages, but that's fine. I hope that they have not changed in a bad way. That's not looking good. Operators, there it is. So here you have like another page where you have like all of the operators as well, and the ones that have a star are the ones that are used the most, because otherwise, like the list is so big that some of them you don't even use it at any point in time, right? So multicast, publish, all of these, buffer, it's they are quite hard. But but for instance, like map, it's marked with a star. So probably this one is something that you would use to. And then here you also find examples and everything. Like this page is really nice. So I'll share both of these.
I shared it already.
Okay, nice, thank you. Cheers. So now I want you to make your own operator. Okay, it's very simple. It's take operator. It's one of the easiest ones, but I think that if you get to work a bit with this sort of like a structure of a function that returns a function that returns an observable, it could help you in the long run as well when you have to work with operators. So try to implement this. Maybe if you don't have the slides, I can just like paste them here and I will commit. So my idea now is that you have to do something that when you do take, so when you run this, it should do the same thing as we had before, right? So it should show you the values from 0 to 18 because I'm taking 10. But you have to implement this. Like if I run this now, nothing will happen because this take is now creating an observable that does nothing. So it's something for you to work. It shouldn't take longer than 15 minutes at most. So I just pushed it to main on the repo that we always have for like getting started and so on. How many people have it done? Okay. Sorry? So it should log all of the numbers from 0 to 18. Well, except by 2 yeah, skipping 2 We can take a look later, I guess. Yeah. So should we solve it together? Or what are the pain points you've found? Or I don't know, like this operator is one of the most simple ones, right? Because all we have to do is just like count how many emissions we've made, and after this amount, then we have to finish. Yeah. So what we need to do is like some sort of like, okay, let's count. So let count is equal to 0. We have not emitted anything. And when we need to emit something from the source back to our subscriber, then we do, well, first we can tell our subscriber, hey, there's a new value. So here it is. And we increment the count. Of course, like, sorry, this is my bad. So here I'm like, oh, this returns an observable of R. And what is this R? I don't have it. I'm sorry if this confused. Like, this was a mistake on the exercise. This R should not be here. It was just like a TypeScript warning of like, I cannot assign V to R because R is not defined and so on. Anyway, so, and now that we have incremented the count, what we have to do is, well, if we have reached our values that we want to take, then we just finish. Yeah, so if count is equal to the amount, then we just tell our subscriber, hey, there are no more messages. We're done, right? And lastly, we just need to do here like subscriber and subscribe in order to essentially like now tell our producer that, you know, we are no longer looking for more things. So if I save this, oh, sorry, subscription, not subscriber. Like this one that we need to cancel. So if I run this, yeah, 18, finished. Yeah. Like this is more or less simple, and that's fine. Also, I just want to notice like more stuff, like, because usually when I see this thing myself, like, because this is my coding style, I usually say like, oh, this is a function that just calls unsubscribe. So I just can't return that function, it would work, right? But that's not the case. If I do this, error. And theoretically, it's doing the same thing. Like I'm here returning a function that's called unsubscribe that takes no arguments, and it should unsubscribe, right? But the thing is that, you know, RxJS works with classes, so this is why I don't like using classes in JavaScript, because, well, this is a bit of a side thing. But if I have has a class potato, and this class has a function, sorry, it's called, I don't know, like get value of, or get weight. So I constructor here, constructor, and I'm gonna say that there's a private weight, which I'm going to say like, well, this weight, it's not random times, I don't know, 100 kilos, 100 grams or whatever. So now I have this number. So get weight is going to return this dot weight, and I create a new potato get weight. And I'll take this out. This would work, right? Like we're expecting this to work. This is just fine. This is not like asynchronous JavaScript or whatever, but it's just to mention something that you want to be careful when using observables. Don't use my coding style of like not using functions. But like essentially this works, right? So I'm calling potato get weight, and I have the weight. Nice. Now what happens if I say I want my function, like my weight function is potato get weight, and I call my weight function? What's going to happen here? Any guess? Will I get the weight? No, right? Because the way that JavaScript functions work within objects is that they have a context, which is this. And this is whatever you're calling the function with. So in this case, when we do, sorry, in the other case, when we did potato get weight, potato get weight, when we did this thing, this function get weight is getting executed as the context of potato. So potato is this, and then it just gets the weight of the potato. Yeah. But if I'm putting this in a separate function and I call it directly, now this function gets called, but this is undefined because there's no context here. So if we take a look at this error, it's undefined is not an object evaluating this weight because we're not passing that. So in here, like there's multiple ways of doing that. Like you can say, well, this function I'm going to call it in the context of potato. So that's another way that you can do the same thing, and now it will work. Yeah. So well, that was some sidetracking just because I don't want you to get confused if you say like, oh, I can just return any subscription, any function here, so this should work. So you can just do this, and this will work again. Okay. I have another exercise for you. Now it's a bit more interesting because we're going to use PAPI for that. So PAPI, the way that it has to give you values is with observables. Okay, because with this primitive, we think that people can build. They can compose observables and they can do stuff with that. We had a question there.
Sorry. I have a small question regarding the last exercise. How does it get pipe? Like when you return, it's a new observable, and you return the cleanup function. How does it the pipe gets like the value from the observable? What before that? Right.
Yeah. So it's getting it from here, right? Like this source over here is, yeah, that's a good question. Sorry, I haven't explained this properly. So this source over here is the observable that we're passing to the operator. And how does this get passed along? With pipe, okay? So what this pipe is doing is taking this observable right here, which is interval 200, and passing it to the result of this operator, which, if I do this, now I can say that the result of this map is a function that takes an assert. So this is taking this observable right here and passing it to this one. Yeah. Now this operator returns a new observable, as we have seen. and the result of this observable, it passes down to the next operator. So this is another, take 10, it's another source, okay? We were speaking about the TC39. I think it's in stage 2, so it's better than observables, yeah, that they will introduce this operator right here in JavaScript, and it's called the pipe operator. And what this pipe operator will do is exactly this. Like, then when this operator lands, you can do that. Interval 200, and then you will do this of map, essentially this thing. Because this, what it's called piping, it's something that comes from functional programming. And the idea is that you take whatever this function is, whatever the result of this is, you pass it down to the result of that, right? And then whatever the result of that, you pass it down to the result of that. So this is equivalent to doing interval 200. And now I'm going to wrap this with map, right? Like the result of interval, I'm passing it to map. And now the result of this, I'm passing it to take. So it's doing this thing of like, wrapping and wrapping and wrapping. And then the observable or something just gets passed along into the next observable. Now, of course, like if we were to write stuff like this way, it would be like extremely confusing to see how the order is and everything, like it's all messed up. So this is why we do this pipe. It just looks way better, right? And when we have this operator, it will be much better. But for the time being, what we have is just this. And then we have to understand that what's happening here is that we have an observable, we transform it in some way, and then we get a new observable, and then we transform it in another way, and we get another observable, and goes down the pipeline.
Okay, so it's like composing functions that is the other way around, like the callbacks and
Yes.
yeah,
Yes.
I get it. Thank you.
Thank you for the question, because it was okay. So yeah, what I was going to say is that in PAPI, what we have for when you want to watch a value and you want to do like a push operation, is we return observables. Yeah. So let's create the typed API here. We're connected to Polkadot. Yeah, no. I don't know Polkadot, sorry. Un paseo. So typed API is client get typed API of paseo that I have in my descriptors. And now I have typed API, and I can do query of sudo key watch value. So now what this is returning is an observable of the sudo key. Yes. So if I subscribe, here I could like log this sudo key. Sudo key is that result, right? And now the exercise is going to be create like an observable that essentially gives me the account of the sudo key. So the other place where we have the account is query account, system account. We can also do watch value. And then here we need to pass in a key, which is going to be the sudo key. And the exercise here that I want to do by yourself is like, try to figure out how to combine these two things, or how to chain these two things, rather, right? So here we have like an operation, a query operation that is going to give us the sudo key. And now when we have the sudo key, we need to get the account. Yeah. There's one way of doing it, which is callback help, but there's another way of doing it, which is using some operators. So like if you find an operator that can help you with that, then go ahead. Otherwise, like just try with the easy way, which would be like nesting your subscriptions. And I'll commit this thing. Take solution and then sudo account exercise. same thing, like 10 minutes. Because like if you know the operator, then it's immediate. Otherwise, you have to look. And if you don't know the operator and want to do it the old way, then it's also quite straightforward, I would say. So that's good. We can do lesson together. So how was it? Well, now we will see Nikos solve the exercise for you. Yeah, that's fine. Anyway. Yeah. Yeah. Anyway, how many of you did manage to solve this? Nikos and oh, nice. We have many people. Okay, so well, like the first thing that we could solve it if we don't know operators, it's just like, well, just nest it, right? But then it's like, what is the point of observables if we have to nest one thing into the other, right? So here, well, here we have the key, and then we would pass the key here, and I'm gonna say that the key is always there because we know it is. And then I subscribe, and then here I receive the value, and I could just console log the value. So this looks fine, but there's a massive problem here. Can you tell what's the problem of this? Someone? Like, first of all, will this work? Yes or no? That's the question. Like, will I receive the value of the system of the account of the sudo key? Don't be shy. Yes, I will. Right? I'm getting the sudo key watch value. So here I will receive the key whenever it is, and then also when it changes. And then I'm doing system account watch value of that key, which will work, and I'm getting the value. This will work, right? Like if I run this npm there, we will see that this is indeed working, and there are no problems. 5173, it's here. After small.connects. It should be coming really, really soon. Come on, small, you can do it. Okay, yeah. Now we have it. Yay. Okay. Oof. So it does work. Okay, so we can say like, oh, like this works and it's fine. But this is not correct. Like there's a massive problem that this one has. Yeah.
It's creating a subscription for every time the key updates. So
exactly, right? So it works for the first key, right? Like we have gotten the sudo key, and now we're watching the value. And every time that the count value changes, we will get a new notification for that. But if someone changes the sudo key, and now we get a new sudo key, then this function will run again, and it will receive the new value. Yes? So, well, we will receive the new value, but the old key is still running. It's like the old system account with the old key is still running, and will keep like giving us updates. So here we would have to do something like of like having here a subscription. So I can have like a subscription or null. And then if we had a subscription from before, then I'm going to cancel the subscription. Subscription. Oh, come on. I don't know why sometimes it does this, but it doesn't want to import. Subscription. There you go. So subscription. Yeah, I know, but then why are you giving me? It's subscription. Well, subscription and subscribe. I know why. It's telling me never is not assignable, because here like TypeScript is very, very smart, and it's like hey, here you have a subscription that you have told me that this is this type, and you have assigned it to null, but you're not assigning it anywhere else. So this thing will never happen. So because it will never happen, subscription is of type never. Anyway, now when I put this thing here, subscription is equal to that, now it works. Okay, because now it detects like, oh yeah, you are assigning it, and then it can be a subscription. So this is okay. So I'm putting subscription and subscribe and setting up anyone. So now this is more correct. Okay. Now this sucks, right? Like we don't want to do this. Like imagine like if like this is like something really simple. Like we are just combining two different operations, putting them together. Imagine that, you know, for more complex scenarios, you have to do more nesting. So this is when operators come into play, which is that instead of doing all of this, and instead of so I will actually commit this just if someone wants to have it as a reference. Git add my solution. And what I'm gonna do now is, yeah, I can just remove this subscribe and everything. I can even subscribe it. And now we're gonna pipe, and I also don't need a subscription anymore. And now we can use an operator that there's actually like two different ways of doing it. So essentially, like what we want to do, like, is nest one observable inside the other, right? So if we were to map this, so we receive the key, and this key we just put like type API query system account what's value of this key. What we receive here comes result is, sorry, I need to put this, is an observable of that, right? Because when we map one value to another, here we are returning an observable. So it will map each one of the values that come through here, which is our string, into a new observable. So what we need to do is what in functional programming is called flattening. Yes? So this is also like an array. In array, like if we have an array of arrays, so we have 1, 2, 3, 4, 5, 6. We have a function into an array which flattens, which is array.flat, right? And what this returns is just one single array of numbers, which is, you know, 1, 2, 3, 4, 5, 6. Yeah, it just takes that, and so what we need to do here is flatten this. So how do we do that? Well, there's two ways of doing it, and the most simple one is just calling directly. Let me see if they actually have it. They have it, but it's deprecated, and we will talk about this soon. But they do have a flat map operator, just like an array. Like in here, we could do array.flatmap, and it's the same thing. It's the same concept. It's like for each one of the values of this array, I'm going to return from this function another array that should be flattened directly, right? So when we come here and we do what value pipe flat map into that, we have an observable of what we're looking for. And now, subscribe, this will work. Removing the array thing. Whenever small dot, like in here, I could have used a WebSocket connection just so that we don't have to wait that much. But yeah, like this should work, okay? Now, why is this thing deprecated? Who can guess? Sorry? I didn't fully get that. Microphone, please. No, okay. I guess that was, anyway. So, well, first of all, like you understand what this thing is doing, right? Is there any question on that? Please raise your hand. Like this is important to understand before we keep continuing. Otherwise, you will get lost. Yeah, then I guess it's clear. So what's happening here is that flat map it's a bit ambiguous because the way that you have flattened an observable with other observables, there are multiple ways of doing it, right? So what do I mean by that? So remember, like an observable is not something like we have an array where we have all of the values one by one and we can just like emit one at a time, right? An observable is something that lives over time. So you might want to say like, okay, imagine that we do like pseudo watch value, and then for this particular thing, we want to fetch some information about this pseudo key that will take a while, but we don't want this thing to be canceled, right? We want that, if we get a new pseudo key, we want to wait. We want to wait like for the previous operation to finish and give us a result, and so that we can have the result of the previous key with a new key that's coming through. So this is one interpretation that someone could have, right? Or another interpretation that another could have is like, no. Like, I don't care about the previous pseudo key value. So as soon as I get like a new value, I want you to cancel the previous operation and start a new one for the new one. Or you could have another one, which is like, well, like maybe why not both, right? Like maybe don't cancel the previous one, but you can start the new operation, and if you give me like the result in different order, then it's fine. So this flat map has like so many different meanings that what they did is like they split it up into 4 different operators, which is a lot, but it's fine. Like it just covers each one of the cases. So we have switch map, which is probably what I would use for this thing. So what switch map says is like, if there was something running here, cancel that thing and begin a new one. Okay, so it will stop the previous one, and then we'll start a new one. This is the equivalent to what we had with the nested subscriptions and everything. Yeah. Then we have another one, which is merge map. So merge map, what it's doing is it's also flattening it, but it doesn't cancel the previous operations. So this is the equivalent to the wrong version where we were not canceling the previous things. So this thing will just like keep accumulating values. So in this case, usually what you would do here is like, well, instead of doing something that runs indefinitely, right? Like here we are just like watching a value of a system account. What you would do here is like, okay, I don't know, like just give me 100 of each, and then I'm going to finish them. So you need some sort of like mechanism in this case to tell when you want the operation that's inside here to end, right? Then we have a couple more. We have a concat map, which what this thing is doing, what this thing would do, it's similar to the previous one. So it's like, okay, when there's a new change on this key, do not cancel the previous one, but do a concat. So it means that wait until this one finishes before starting the next one. And then, when this one finishes, you start the next query, and the next query will start and give new values. And these values will get pushed to result, but they will come in order. But then for this one, you also need a mechanism here to say like, well, this has to finish at some point. So, you would say like, oh, imagine that it's like, I want to get the 3 values, the 3 changes of a system account of each one of the pseudo keys that come through. I don't know. This is very made up, but and the last one, it looks extremely niche. Like there's no way I would use it in this example, but there are use cases for that, which is a cross map. And what this thing does is, if there's an operation going on here and a new value comes through, discard the new value. So don't do anything with that value. Okay, so let's think like different scenarios of like how we can use this operator. So like in this scenario, you would use switch map because it's like, okay, what I want to have is the pseudo key balance, right? What I want to have is this thing. So If the pseudo key changes, then don't give me values from the previous one. So this is why I would do like a switch map without the take tree. This is pretty clear. But what about merge map? What could be a use case of that? Well, we can think of it like, imagine that you have a UI that you can upload photos to, right? And you want the user to be able to submit multiple photos simultaneously, right? Then you would have a button at some point, and then that button on click, you would do something like merge map. That when you get a new click, then like with the form value of like the file, you would do like upload to my server, upload to server this form value, right? And then essentially with merge map, you could do something that you have multiple things that can happen simultaneously, and you don't care like if it's going one after the other. This could be one. Yeah. Now let's say another use case. Yeah, for instance, like let's say that you want to do transactions, right? So transactions in a dApp, you could say that you want to happen then one after the other. What would you use for that? Remember, we had merge map, switch map, we had concat map, we had exhaust map. We had like these 4.
I don't know if this is the right answer, but if those transactions need to be combined and added to maybe a single transaction, maybe thinking like a bundles transaction at some point, then concat map might be useful.
Yeah, well, like this is all my dApp scenario that I'm just making in the spot. But yeah, like what I was trying to look here is concat map, right? Like imagine that the dApp, you have like a button that the user can click of like, hey, I want to transfer to this guy and to this guy, to this guy. But you know that there's a nonce that transactions have to happen in an order. So when you let the user like queue up sort of like transactions, but they don't happen like simultaneously. First you send one, then the nonce gets updated, and then you send the next one, and you send the next one, and you send the next one. So in this case, you would use a concat map because every time that the user is clicking the button, you don't want to cancel the other or like happen things simultaneously, right? And another use case for the exhaust map is at certain places like, so imagine that you have something that is like updating like extremely quickly. So the price of, you're connected to the Hydra API that gives you the price of a value, right? And based on that price, you want to make a request to do something else. So if the thing is like going like extremely fast, if you do merge map, that's a bit too wasteful. You would be like doing one extra request per every single change. That's not a good thing. If you do switch map, this could look good because now it's like, oh, I'm not sending more requests than like I just have one request at a time. But now the problem is that because you're receiving this value so fast, every single value is canceling the previous operation. So you will never get any value out of that. Then concat map, this is also back pressure, what I mentioned initially. So concat map has this problem of back pressure. You have to be very careful when you use concat map, because if you use concat map on a source that is emitting so fast, all of those values get stored in memory before, and they cannot run before the previous one has started running and finished and completed, right? So you have to be extremely careful for that. That's not a good option. But with the exhaust map, this would be a good scenario, because with the exhaust map, it's like, okay, I'm receiving a new change, I'm starting a new request, and now I don't care if this value changes like multiple times, because like the price doesn't change that much. So I'm doing something with that. But when I finish, if it changes again, then please notify me, right? So this is what exhaust map is meant for. It's extremely nice. Like usually, the ones you would use the most is, I think by order, first switch map, then merge map, then concat, and then exhaust. Yeah. Okay, something else I want to mention on this, and it has to do with PAPI and when you use this thing in your assignment and so on, is remember that observables are called by default. Called by default, it means of this thing that remember when we had like new observable and we had a subscriber inside, and then everything started when someone subscribed to it. This is the meaning of called, right? Like if I do this thing, sudo key balance, and I don't do anything with this, PAPI will not query any of this. So I'm calling type API query sudo key watch value. So it looks like I'm telling PAPI, hey, I want to watch the value of this. So please start getting values. But PAPI is not doing anything just yet. When it starts is when you subscribe to it. When you subscribe, then everything starts. And this is like a common pattern, but it's all in observables. So when you have an observable, it doesn't do anything until you subscribe to it. Okay? So this is especially important when we do type API, transaction, system remark, remark binary from hex, from text. Hello. So here I'm doing a system remark, and this gives me a transaction. I still haven't done anything, but I can do sign, submit, and watch. And here I need a polka signer that I don't have, so sorry about that. I'll just not do it. But this is giving me an observable. Yeah, remember that like on a previous day, what we did directly was just like subscribe to it to start receiving values. But what this is returning is an observable that you can compose with other stuff. So now, if you come here and I say like, oh, I want, this is, I have a slide a bit more. So the thing is, if you do this, like I have done sign, submit, and watch, and actually if I save, I don't think that this will blow up. It doesn't blow up. So even though I have put here a null, which should blow up with a null, it doesn't even blow up. And why is that? Because I have not subscribed yet, right? So this is an observable that when someone subscribes, will start doing all of the process work. So if I come here and I do transaction.subscribe, and I don't even need to listen to anything. Well, this is awkward. This should blow up, and it's not. Do I have an await somewhere? No, I know why it's not blowing up, because, okay, yeah, internally it's starting to do stuff, but first it needs to verify if the transaction is valid and all of that. So it's waiting until small dot is ready. And now that the small dot is ready, now it blow up. Cannot read properties of null public key, right? So this, like the fact that this is low is killing me. Let me connect to a real environment, to an RPC on Paseo. Paseo relay. Here we go. Add WebSocket provider. So I have here my thing, and I don't want this to blow up, so I will also say like funds extension is connect injected extension of polka.js, because I have polka.js in the machine, and then account it's await extension. Oh, I think then this is synchronous, right? Yeah. Find the account that the name is PBA Oliva. I will consult the account just in case I will not lose this. Okay. Run. Sign, submit, and watch of this account. Polkadot signer. Okay, so I want to subscribe to it, but then I don't know what's the best way of doing this. What I want to show here is what happens if I do this. Set timeout. Transaction.subscribe. After 3 seconds, hopefully it will be fine. Yeah. So I can also pick this up. So what is your guess that will happen here? So I'm subscribing to this transaction, and after 3 seconds, so hopefully when I have already submitted it, actually I'm gonna give more time. So after 5 seconds, I'm going to make another subscription to the same observable. What's going to happen? Guess?
Some kind of memory leak.
Memory leak? Not exactly, no.
I don't think you would subscribe twice. I think you would unsubscribe and resubscribe. Like your second subscribe would just overwrite because it's on the same TX property or TX object.
No, like remember what we had before, right? We had like one observable, which was emitting the values from 1 to 10. And then we had like 2 separate subscriptions. And each subscription had their, their own number, essentially, right? There was someone. But on this case, what would happen?
I think it will again try to submit the transaction.
Exactly. Yeah. So this is actually something that you could say like, oh, Papi could actually, solve this. Like we could have made that this observable, if you subscribe more than 1 time to it, it's just like whatever, like you already submitted the transaction and it's not submitting it. But it doesn't. So if you do subscribe and after 5 seconds you do subscribe again, this subscribe will start a new signing process. Let's give this a try. If I come here. Oh, yeah, so this is probably the first one. Oh, and the second one, what happened here? Oh, rate limit exceeded. Okay, this is the node that is not working properly. This is annoying. This node is shouting at me that we are doing too much spam, so it's telling me to go away. So I'll use. Is there like parity? No, parity doesn't happen. Maybe IVP will work. Let's see. Yeah. Oops. This is why small dot is better. You see. Well, here I have my thing, and it's again telling me that's not looking nice. Okay, and I don't have enough funds to pay it. Nice. Anyway, like what will happen here, like in a real scenario, and if like the node is working properly, is that you would see like a pop-up coming in of like, hey, sign this transaction. And then after 5 seconds, another pop-up coming in of like, hey, sign this transaction. Okay? And this is because of like that Papi wants to be consistent with this assumption that all of the observables are called. Okay? So if you want to subscribe twice, then you need to do something about it. Now the question is, what can you do? So for this, we have more operators. We love operators. That is called share. So, right. It's like we have an observable, and this observable, we want to share it with multiple subscribers without triggering this effect. So you can always do share. And if you do that, my transaction is sign, submit, and watch, but then I'm going to share this. Now, when you subscribe multiple times to this, what is going to happen is that this subscriber will reuse the same subscription that this one has, and then it will receive the values that that subscription is emitting to. So in here, sorry. And then also like you will see that there are multiple. There is also like share replay, and then you pass a number. And with this, you're telling, okay, share this stream, but when a new one comes through, then replay the last one value that you have received. Because again, like there are so many interpretations of that. Usually, you use share replay one if it's like a state, right, more than an event, and you just use share if it's just like one. This is, I think, everything I had to show here. Are there any questions about everything that has been explained here?
Are there any like React libraries that just wrap around these the RxJS?
Wrappers of?
React libraries for like use hooks.
We like, yes, like there are some libraries. The ones that I use is one we built ourselves, essentially. Like Giuseppe and me like meet in a company called Adaptive, but we dealt like with real-time data, and we made essentially like trading applications for that. And in there, like as a sort of like a side project, essentially we built a library that you can use RxJS and connect it with observables. The way that we did it, is that, well, the thing is that there was no really anything that we actually liked. Like at that point, there was a library, I think that used like observables with React, but essentially it came down to coming here and creating here an observable. So you would do like, I don't know, my value is, and then it would be like, I don't know, use observable. And then here you would like create your observables and all of that stuff. The only problem is that what we think of dealing with observables and so on is that it's their own little thing, right? It doesn't make sense to have like an observable inside a React component. That's not something we really like. So if you look at all of our dApps, we are using this library called RxJS, which is what we built. And the idea with that is that you create states outside of your components, and then from inside, you would consume them. So in here, you would create pseudo balance, and it would look more or less like that, what we had here before.
So, if I may, like,
yeah, well,
so I think we're like, this is way out of scope of like, I mean, like
it is, but
I mean, so what I want to explain is the most important takeaways for today's lesson, which is dealing with real-time data, right? Is the primitives that we showed at the beginning, and that you understand the difference between a macro task, a micro task, and synchronous code, and how the combination of these three things that always happen inside JavaScript can screw you over a little bit. Now, in order to deal with these things, right? Sure, there are promises, but promises, as we saw before, they're eager, they are not easily cancelable. You can use signals and whatnot. Now, we wanted to show you one common primitive that it's used inside many libraries, not only RxJS, it's also being used inside MobX, it's also being used inside Rico, it's like, which is the observable. And the observable, like, perhaps one day it's going to be part of ECMAScript. Like, I mean, it's in stage 1. It's unlikely, but perhaps it is. But it's being it's a resourceful construct that, because it's lazy, right? It can help you deal with the complexity of these things. But it comes with its own set of trade-offs, as you have been seeing. Has good things, have bad things. It's for you to decide. We're here not to shield observables. There are other primitives that we didn't have the time to explain. Like, there are other libraries, like for instance, EffectTS has its own observability primitives built on top of generators, you are welcome to look into that. The good thing about learning observables is that all these things that you are learning about composition and higher order functions in order to kind of enhance and encapsulate behavior, like all these things apply also to FFTS and all the other like libraries and flavors, futures and whatnot that are being used for dealing with handling real-time data. So I feel a little bit uncomfortable because there's a library called precisely React.js that we did build, but it's highly opinionated into how you want to handle the state into React, and it's not for everyone. It is definitely not for everyone. And in order to use it effectively, you need to know quite a bit about RxJS, which is not the goal of this. And you need to know a little bit more about React, and you need to know about like the mental models that we're trying to propose. So as much as I'm proud of the library and it's being quite used by, like, you can look at the number of downloads, like it's not been promoted and stuff, and people use it, like, I don't know, like has a few thousand weekly downloads, like I don't know how many, but like a few, and people from the world companies still use it. It's not for everyone, and it's not going to grant you any extra points. Like you're not going to look cool if you use it in your assignment. Like if it's useful for you, use it. If it's confusing you and it's slowing you down, don't use it. But just because we wrote it, like what I'm trying to say is like, we're not here to shield observables or libraries. We're here, the main goal is to kind of explain so that you can use, anyways, sorry, I kind of hijack into, but yeah, so I will much rather if we don't get into the
No, like
Yeah.
I wasn't going to do it.
Okay,
like,
okay.
Yeah, like I totally agree. Like as I said in the introduction, like observables is something that is getting into the standard of JavaScript. It's not yet there. It's like in stage 1 and it will probably for a long time. But there are many libraries that deal with that, right? And I have shown RxJS just because there's a large community around it. But there are also like others, and you know, as he said, like there's another one, Effect, that is now coming into fruition, and that's also one. But yeah, I just wanted to show that there are like different ones, and you know, we chose this one, and you know, it's essentially like the idea of that one is like, you know, you create your observables outside of your components, and then inside you just like consume them. So you would do like cons, the balance is state observable or whatever of this pseudo balance, right? And now you have your balance in here. But again, like this is not part of this lesson, just because for the assignment you don't really need this in reality. But that's again, like if you want to, maybe you can share a link or whatever, but it's not. Don't stress about it. Yeah. But yeah, like good question. Any other? All right. So now, yeah, like as I said before, like the observables have interoperability with promises, but you need to be careful with them, okay? Because like it's not apples to apples, right? So first of all, like if you have an observable, remember that an observable has multiple values and the promise only has one, right? So you need to say like, well, okay, I want to turn it into a promise, but how? So RxJS just exports two functions: first value from and last value from, and this return a promise, right? So first value from, you pass in an observable, and the first value that this observable emits will resolve the promise, and then it will unsubscribe from this observable. Yeah. And last value from subscribes to the observable. The observable can emit as many values as it wants, and then when it completes, it will resolve the promise with the last value that was emitted. Now, with this, you can do anything else. Like, imagine that you want like you want a promise that resolves with all of the values that have been emitted by an observable. Then you can just compose it, right? So you have an observable of numbers. You can do pipe, and then you can accumulate each one of the values into an array, and then your last value from, and then you will get the last value of that observable, which will be an array of all of the values that have been emitted. Yeah. And then when you want to turn it the other way around, you also need to be careful. So there are two different operators. One is from, and from takes in an array or a promise or anything that looks like a producer of information and turns it into an observable. So you can do from fetch and you pass in that, and then you got an observable. Or you have a defer that takes in a function that does something asynchronous and can also return an array, a promise, or also another observable, and will also resolve with that. But from the name, who can tell me which is the difference between these two? Note, there's a function here. So that's a big clue. Something in the back.
So maybe the one with defer will be asynchronously called?
Asynchronously, almost, but no. Yeah, you're in the right track. I think that depending on how I interpret your answer, it's actually correct, right? So when we do from fetch, what's happening here? We are calling fetch first, getting the promise, putting it in here, and then doing from. So it will fetch the value and then put it into an observable. So now that when we subscribe to this observable, the value will already started loading and maybe it will get there. But defer, we pass in a function that doesn't do anything yet. So it's like, okay, I have an observable that, it's like this defer, but the fetch has not already happened because no one has called this function. Yeah. And now, when someone subscribes to this observable is when this function gets called and the fetch starts. So why is this important is because imagine in here, in the switch map, in here, imagine that we don't like watch value, we want get value. This is a bad example, actually. Let me think of a better example. This is I don't have a great example here, but my idea is imagine that you have some ID in some place, and then you have these two. And then you have a function that is get my observable that returns these two. So it's I'm calling this from dollar, and this I'm calling defer dollar. And I'm just returning both of these, okay? So from and this is not a good example either. Sorry. What I'm trying to find an example here, but I'm also making it at the spot, has to do with the fact that you can subscribe to this multiple times, right? I can subscribe one time here, and then maybe in a set time out, I can subscribe again. 5,000. And then what I'm doing here is okay, I'm fetching something from somewhere that has this ID in. So I'm putting this, and then HTTP, and then something plus ID. So both of these look equivalent to each other, right? If I do from subscribe, then I will receive the value for the ID. But then after a while, I do ID is equal to 5, and now I do from subscribe again. So you could think oh, this will work, right? Because I'm just updating the 5, so this will fetch again, and we'll get the new ID, and so on. But that's not true, right? Because what's happening here is that this fetch has captured this ID. It has put it inside the string, and now it's just a promise that already resolved. So if you subscribe to it multiple times, you will always receive the same value. It will not update this ID because it was already there. Yeah. And if you use defer, then every time that you subscribe, you will receive a new fetch, and so this ID will be essentially connected with the other one. It's a bit of a the thing is that I have found real cases where doing this has beaten me in the ass. Okay, so when you try to combine observables and promises, first of all, try not to. But if you have to, then be mindful about all of these things. Yeah, well, this is a bit like more or less what I mentioned of like we can there's pull and push operations on each one of the stuff, and we have already talked about switch map markup and concat and so on. But now I want to comment on the pain points, which I think lunchtime it's 12:30, right? Yeah, I do have time for that. So everything I've mentioned is like, oh, look how observables make your life easier because you don't have to do callback hell when you want to deal with real-time data and subscriptions and whatnot. You can combine and so on. But there's some problems that you need to be aware of that deal with concurrency. And unfortunately, observables don't solve all of these problems. You're still responsible to figure out those things. So one of the things that to me is the most annoying about observables is repeated computations. So there's an observable called combine latest that I'm going to just put it here. So let's say that they have a bunch of observables. So I'm just going to create like a lot of intervals. On RxJS test, I'll put them, sorry. I don't lose this. So in here on RxJS test, I'm going back and I'm creating a bunch of observables. A interval every 100 milliseconds, A, B, C. But now this is multiplied by 2, map value multiplied value by 2, and this is value is divided by 2. And now there's a combination operator which takes multiple observables and will emit values whenever each one of them changes. So there's a combine latest, and I can put in a list of observables, which is A, B, and C. And now what I receive here is an observable that has A, B, and C, but the values of each one of these. Okay, so anytime that anytime that one of these changes, then I will receive a new value with the latest of each one of them. Okay, this makes sense. So in here, I'm gonna say like, oh, this is really fine. So I'm putting an interval of like every 200 milliseconds, 200 milliseconds of different values, and whenever they change, I want to calculate the multiplication of all of them. Return that. But what we're gonna see here, result, result, is that this is a bit annoying. So I will actually do it every second to make it a bit more apparent. Otherwise, we will get bombarded. Run. Source RxJS test. Are you seeing this? The values are not coming one by one, right? They are coming like 3 by 3, like. So in a way, I would expect like, well, I just want to get like the latest value of each one of these ones. So each one is incrementing one by one. So after 1 second, one of them changes, and then it will give me the value of all of them, right? But that's not true because each one of them is getting incremented individually. So when the first one updates, this combined latest will see, oh, here we have a new update. So it will give me the new value of A, then B, C, yeah? And then the B changes, and then we have that. So sometimes you have, like when you have like a big application with so many observables, and you have, especially when you have observables that, they are related to each other. So you could say like, imagine that C, for instance, is a combined latest of A and B, and it's like, oh, I'm going to add these two numbers. So map A, B, A plus B. Now this is even worse. In here, I will get like, I don't know how many, 4, 5, something like that. Because now what's happening here is that this observable is getting repeated twice, 2 times, every time that, on every second. And then because this gets repeated 2 times, now this thing is getting computed 2 times again. So this is a bit annoying. And the way you have to solve it is don't go overboard on creating like very, very fast observables that, they are super combined with each other. Like you have to find a sweet spot between having observables that are self-contained, right? That they have a purpose of existing, but without going to overboard of like, oh, I'm going to make everything so small that it's going to be super efficient.
Yeah, I think we lost your mic. I think we lost your mic. Can't hear you very well anymore.
Oh. I probably talk too much, so this is why. Anyway, so this is one of the pain points. So I don't, like, there's no easy solution to that. Like, there's no one recipe, but as you get to work with observables, it's something that you often find. Another problem here is value, what I call value not yet there. So there's like an operator called with latest from, which you would use it more or less like so. So it's like, oh, imagine that, because like combine latest has this problem, right? That every time that one of these changes, then you get an update. But you could say like, oh, what I want to do here is that I only want to calculate this whenever this changes, but then when this happens, just get the latest value from C. And then you could do, well, the only thing is that here is like nested, inside nested. So this is a bit, on the types is a bit hard to put it, but it's like that. So this is a perfectly valid observable. The only problem is that this with the latest from literally takes the latest from this. Okay, so now it depends on, when A emits a value, it will emit this value to this observable over here of Kanban latest, but also to this observable right here. So now it depends on which one of these two runs first before like C can get an update. So imagine like if A changes and gets this value here, and it runs this one first, then combine latest will trigger, and we will get the value, and C will get the update, and then C will notify this one, right? So now when A continues notifying new subscribers and comes here and notifies this one, when we come here with latest from, we'll have the correct value of C. But if it happens the other way around, that first A notifies this one, then the problem is that this combine latest will trigger, then with latest from, we'll grab the previous value of C, because it's the latest value that it has received. So when we come here, you will see that there's like a different value. So actually, there's an example of this, which we can recreate. So here, like instead of like doing something that runs on an interval, I'm just creating something that I can manually push. So it's a subject as we've seen before, but it's called behavior subject because it always has a value. Okay, like it's not that important. But then what I can do here is like, okay, I'm going to combine latest this, and let's say I want this to be shared. Because I only want one subscription for C, I don't want to recompute this for every single subscriber. So I'm just like going to share it to multiple subscribers and whatnot. So what I can do here is like, okay, now here C is like the sum, so I'm going to give this like a proper name. This is the sum of A and B. And when I come here, I want to, I don't even need to map. What I want to do here is, I will take this and directly subscribe and just console log my super result. So I come here and say A plus B is equal to C. And this looks like it should work. And I think that this will work actually, if I do one run. Okay, I need more than one, please. Right. So after what happened here is that A and B are not observables, they are not emitting. They just have the value 0. So we just get the value and that's all. What we have to do is just say like, okay, I want A to now become 1. Okay, so I'm just pushing the value 1 to this one. And I think that this will work. Yeah, it does. So 0 plus 0 is 0, 1 plus 0 is 0, is 1. But now let's do something else, which is like in here, let's say that someone else is watching this sum. So now if I run this, okay, this is unexpected. Let me see what it's going wrong. Subscribe. Yeah, but I feel like this is shared. Have an example where this actually should trigger the correct thing. Let me see. Because I actually, this was a real use case of someone who said like, hey, RxJS is not working. And they had exactly this scenario in place. Yeah. No, but this is not needed. It could be like with a new version, they actually fixed this. But the problem here, oh, well, yeah, I'm console logging here, right? Like the only difference here is that they have a share replay here, but it does, yeah. Like value console log, like in here I can log this and it will just log my sum 0, 1. It could be like that RxJS has done something under the code to sort of fix this, but this is still relevant on some use cases. And the problem here, what happened at least back then, is that with this we were forcing this observable to become alive. Okay, so we forced this to get notified before this one actually subscribed to it. And actually, I think I know. Anyway, so the problem that you would have seen if that thing was not fixed somehow, when they did like some extreme magic, is that in here you would see, no, I know what's going on. It's that it's not the latest from sum. So this is the problem. That's the one. This is the one I'm looking for. So I want A and B. So it's like I want the sum, but with the latest from A and B. So now if I do this, I think that this will actually work. So I have the sum here, and I'm receiving A and B. This should, why is it not liking that? Maybe like that. Yeah. Like, one. Now. Okay, I think that this should do it. Yes. So it was this case exactly. So you can see that, in theory, like we have received the sum, and the sum is 1. But then when this observable tries to replicate this thing, and it's like, okay, give me the sum with the latest value from A and B. Then what happens is that it tells you 0 plus 0 is equal to 1. Right? And what's happening here has to do with the order of subscription. So the problem is that with this subscribe over here, like if we remove it, this thing is fixed. Okay, if I do this, now this problem doesn't happen anymore. And the reason for this is because when we do this, when we put some subscribe, then we're making this observable subscribe to A and B first. So this is the observable that will receive this update first before that one. Okay. And then when what happens is we update A, this thing gets triggered, some changes, then some changes here. It comes with latest from, but it does not receive the latest value of those two, right? And you could say like, and why does it happen if I remove this? Well, the answer is because remember, observables are lazy, right? They are cold. So this, you declare this and nothing subscribes to anything because no one has subscribed yet. And now when we come here and we subscribe, the first thing that subscribes is with latest from, and it subscribes to A and B. So this is the first subscriber of these two observables, and then subscribes to some that subscribes to A and B. So when A changes, first it goes to with latest from, and then it goes to this one. So this is why then we get the correct result. So yeah, like when you work with observables, you will run into this thing, especially like as a beginner, it's a big pain, and then you have to debug it. It's like like when you're in this case, and maybe in here, like it's a bit obvious, right? Like what is this thing doing here in the middle? But sometimes like you are exporting this into another file, and then in another file you have another place. So you have to be a bit careful, especially when using both combined latest and with latest from. They are very useful, but they are quite dangerous. So another way that you can avoid this is with more operators, of course. So you could say here, there's an operator in here that you could say like, well, I want to observe this on a different scheduler. Like this is too advanced. But yeah, like that's not like the idea here is like this operator. You can tell it like instead of subscribing to this synchronously immediately now, you can tell it subscribe in a macro task. So you can say like a subscheduler, and this means as soon as possible, but not synchronously. So it creates a macro task. Anyway, like this is out of scope of this. But yeah, essentially, try to be careful with these cases. And this is all I have. Let's see. Yeah. So as key takeaways, though, I want to repeat a bit what Joseph said, right? Like, don't take this of like, oh, I have to do this with RxJS, and no, like RxJS is just one of the libraries that currently has a lot of community and has a lot of support and all of that. But there are other things coming through, and the value of this lesson is more about thinking about how to work asynchronously and what things to look for, and how to combine different stuff and all of that.